So what I would like to do is just show you how to tell some stuff about a graph by its equation. So if I look, what I'm going to do is make this bigger. Sorry. I'll do that in a minute. All right. Y equals x squared. What is the shape of this graph? It's that's not a shape. A quadratic is the type. It is a smiley face graph. And then y equals negative x squared is a frowny face graph. Now, we've already talked about turning points, right? Now, there are two types of turning points. There is a maximum turning point and a minimum turning point. Well, that is not how you spell minimum. Minimum turning point. Max and min. This is clearly a minimum turning point because it's the minimum point of the graph. Okay? This is going to be a maximum turning point because it's the maximum point of that graph. Make sense? So sometimes you will be asked, does this graph have a max or a min turning point? And you need to be able to tell me which one. There is no need for you to draw it. You should just be able to tell from the equation. If it's a positive x squared term, it will be a minimum turning point. If it's a negative x squared term, it will be a maximum turning point because that's the shape. It doesn't matter where it is. You should know that by whether it's positive or negative. The same is true for cubic graphs. So if I say y equals x cubed, does it start at the bottom or the top? Bottom. It looks like this. There are two turning points. Which one comes first? Right, a max. This is a max. This is a min. So if it's a positive cubic graph, you start with the maxes on the left and the min is on the right. And then the opposite is going to be true for my negative cubic graph. I'm going to hit a minimum turning point first and then a maximum turning point second. So you don't need to worry about any other ones, just quadratics and cubics for this. So you should just be, this is why we've already been talking about knowing the shape of the graph from the equation so we can tell certain things like that. So if I give you, let's do an example of this. Let's save that. Let's do an example where we're finding the turning point and deciding whether it's a maximum or a minimum turning point. Right, I'll put this back up later. So let's say that I have y equals 2x cubed minus 3x squared plus 1. All right, I want to find, find the turning points and are they a min or a max, right? So you need to tell me each one. That's terrible writing, but you get my point. So how do I find the turning points? What's the first thing I'm going to do? Right, I'm going to find the derivative because what is the gradient at the turning point? 0, right? They stop briefly. So I need to find the gradient equation so I can make that equal 0. So what is dy dx of this equation? 6x squared minus 6x. Whoa. All right, now there are multiple ways that I can solve this. I think the easiest one is factorizing. But you can always use the quadratic formula. What is a in this equation? 6. What's b? Negative 6. What's c? 0. There's nothing here. But what I'm going to do is factorize. So what is my common factor?
6. Yeah. 6x.
6x is my common factor. What's left here? What's left here? Minus 1. Anything divided by itself is 1. So for this equation to be true, I hate my computer right now.
That's good.
For this equation to be true, for this to equal 0, either this has to equal 0 or this, because anything times 0 is 0. So what does this x equal? 0. What does this one equal? 1. 1 minus 1 is 0. So those are my two turning points. The x coordinate. Now, some of you were still making mistakes with this and thinking this is the turning point. These are the two x coordinates of the two turning points. This is a positive cubic graph. So does it start at the bottom or the top? Starts at the bottom. So it's going to look like that. And that means that one of the turning points is here. One of them is here. This coordinate is 0. This coordinate is 1. I don't know the y ones yet. All I found is the x ones. Well, the 0 has to be the one on the left, right? Because 1 is after 0. I hope we can tell that. So how am I going to get the y coordinate? Good. Put it back into the original equation, not the derived one, because you'll just get 0. We're going to put it into the original. So 2 times 0 cubed minus 3 times 0 squared plus 1 is 1. So that means this coordinate is 1. When x is 0, y is 1. We're going to do the same thing with 1. 2 times 1 cubed minus 3 times 1 squared plus 1 is 0. Good. So this is 2 minus 3, which is negative 1, plus 1 is 0. That means this coordinate is 1, 0. Now, tell me, is the first one a min or a max?
Max.
Right? We know it's a max because this is a positive cubic graph. So we're going to hit a max one first, and this is a min. It's the bottom section. Now, we don't say it is the maximum point of the graph, because is it?
No.
No, over here it goes up. Is this the minimum point of the graph? No, because this goes further down. This is what we call a local maximum and a local minimum. If it's a quadratic, it is just a max and min turning point, because that is the maximum or minimum value for the whole graph. But here we call it a local maximum and a local minimum. Huh? What'd you say? Okay. So this is just the one extra step today. Is it a maximum or a minimum turning point? You should already know how to find turning points. Some of these things are going to be application questions. Some of them are straight up equations. If your equation has brackets in it, what should you do first? Expand them, right? So you need to expand your brackets first, then you can find the derivative. All right, let's do one where let's do a quadratic one instead of a cubic one. Okay. Yeah, yeah. There are two ways to find it. You can either find the derivative or you can do the minus b over 2. All right, guys, let's do it. So we've just been talking up the front about how there are two ways to find the turning point of a quadratic. Let's do both of them. Guys, let's not. Come on, focus. We're going to do both of them, and I'm going to show you how they both work. Let's do exactly what we did then. What do we have to do first? First of all, we know what shape this is, right? So what kind of turning point is it? This is a minimum, right? So we don't even have to do any work this time. Yeah. So what am I going to do to find the turning point? Well, let's find the derivative. So dy dx of this equation is 2x. Good, 2x plus 6. So I'm going to say that at the turning point, the gradient is 0. So negative 6 is 2x. So negative 3 is x. So this coordinate is negative 3. Then what do I do with this? Put it into the original. So minus 3 squared plus 6 times negative 3 minus 4. What's this?
9.
9 minus?
18.
18 minus 4 is?
37. Minus 4. Minus 13.
Minus 13 is good. So that, guys, focus. So that is the coordinate. Let's do it the other way. What did you girls just say is another way to find the turning point?
So minus b over ab.
Good. Minus b over 2a. Remember we did this? Negative b over 2a. Let's show you that it's the same thing. What's negative b?
Negative 6.
Negative 6. Someone using a ruler over 2 times A, which is, so isn't it -3? See how it gets us the same thing, and then if we plug it in, so it doesn't matter which version you use, right? I don't care which one you do, you'll get the right answer either way.
First one.